Hi Calc students, I'm glad you came back. I'm going to now do page 11. So we looked at the case where either sine has an odd power or cosine has an odd power. And the third type is when both sine and cosine are even powers. And so the example that we have here is sine to the fourth x times the cosine to the fourth x dx. So I'm going to go back to page 10 and look at that summary page. So this is what we're looking at right now. The power of sine and cosine are both even. And for this one, what you have to do is to use this reduced power on sine and cosine. And it comes from the double angle formula for cosine. Okay, so if you recall, I'm just going to write this down here on the side. So remember that cosine of 2x has two versions. It's either going to be 2 cosine squared x minus 1, or it is cosine 2x, and that is equal to 1 minus 2 sine squared x. Alright, and then if you solve for cosine in this one here, cosine squared, that's how you get this particular version right here. And then if you solve for sine squared, that's how you get this top version right here. Okay, so basically what you're going to be doing is rewriting each of the cosine squared and sine squared as one of these, this one or this one, and then you're going to be multiplying that through. Okay, now I'm going to go back to my page 11. Alright, so for page problem letter C, I have sine to the fourth x times the cosine to the fourth x. And so I'm going to first of all rewrite it so that it is integral of sine squared x squared and then times cosine squared x squared dx. Okay, and then I'm going to use the formula that I just stated on the previous page. And so then that's going to equal integral. Sine squared x is 1 minus cosine of 2x divided by 2 squared. And then cosine squared x is 1 plus cosine of 2x divided by 2 squared. Okay, now I need to go through the tedious task of multiplying out this whole thing right here. Okay, sorry, I think you couldn't see my paper. Alright, so I need to multiply out this whole thing here. And so in my next line, I end up with I have a 2 squared in the denominator and 2 squared in the denominator here. So what gets taken out of the integral is 1 over 16. And then it's going to be integral of, and I have actually a difference of two perfect squares. I'll just write that out. So then it's going to end up to be 1 minus cosine of, or cosine squared of 2x, and that whole quantity squared. Okay, next what I can do is use the Pythagorean identity, and it's going to be placed on this. And so let me just show you that conversion. So if I have sine squared x that is equal to 1 minus cosine squared x, then I can put a 2x here and a 2x here, and that'll be equivalent. Right, so that's going to be the same thing as writing it as sine squared 2x is equal to 1 minus cosine squared 2x. Okay, so that means that I can rewrite my 1 minus cosine squared 2x as sine squared 2x. Okay, so in my next line, I have 1 over 16 and then integral, and so it'll be sine squared 2x, and that is squared. and then multiplying that out, I have 1 over 16 times the integral of sine to the 4th 2x dx. Okay, so now what I can do is I'm going to do a u sub on this and let u equal 2x, so then du is equal to 2 dx. So then I have 1/2 du is equal to dx. Okay, so then I'm going to make that substitution. So I have a half from here, and then I have a 1 over 16, so what comes out in front of the integral is 1 over 32. And then I have integral of sine to the 4th u du. Okay, and then putting all that together, that would be the same thing as 1 over 32, and then I have integral of sine squared u, and then you're going to square that du. Okay, so now I'm going to apply the cosine double angle formula on this again, which will give me 1 over 32, and then it's times the integral of 1 minus cosine of 2u divided by 2, and then that's going to be squared du. And then this gets squared, so now the factor that comes out is 1 over 128. And then I'm going to just FOIL out what's inside here. Okay, inside right here. So that's going to be 1 minus 2 times the cosine of 2u plus cosine squared of 2u du. Now this part right here, okay, I can actually rewrite this. And the way that I can rewrite it is, I know my one version is if I have the cosine squared of x, that's going to equal 1 minus, actually I'm sorry, it's 1 plus cosine 2x divided by 2. Okay, so if I make this as a 2u, then that'll give me cosine squared 2u, and that is equal to 1 plus cosine of 4u divided by 2. Okay, so in place of that I'm going to put this 1 plus cosine of 4u divided by 2. Alright, so my next line on this is kind of a long problem, and then that's going to equal, so I have my factor of 1 over 128, and then times the integral 1 minus 2 times the cosine of 2u, and then I'm going to rewrite this last one right here as plus 1 plus cosine of 4u divided by 2 du. Okay, so I'm going to now just clean up some of these fractions, and so I have a half right here, and then I'm going to now combine some of these together, and so I end up with 1 over 128 times the integral of, and so I have a 1 and a 1/2, so that'll be a 3/2, and then it's minus, and then it's going to be a 2 cosine of 2u, and then the last part is plus 1/2 cosine of 4u, and that's du. Okay, I think now I'm ready to actually do the integration. So that gives me 1 over 128, and then I end up with 3/2 u minus sine of 2u plus 1/8 sine of 4u plus c. And now wherever I see my u, I'm going to substitute it for 2x. Okay, so remember, going back up at the top here, I have u is equal to 2x. So I just need to put a 2x with everything. Okay, so then I end up with 1 over 128 integral, and then it's 3/2 times 2x minus sine of 2 times 2x plus 1/8 sine of 4 times 2x plus c. And then simplifying all that, I'll just write it as one equation on this. You come out with 3 over 128x minus 1 over 128 sine 4x plus 1 over 1024 sine of 8x plus c. Okay, so that's when both sine and cosine are evens. Alright, let's do another problem, which is you have actually a composition on this. Actually, these are a little bit easier, and so I'm going to use a u sub of u equaling sine of 3x. Okay, so whichever one has the higher power or something other than just sine or cosine, so you have sine to the 5th, then that's what the u sub is going to be. So then du is going to equal, I'm going to use the chain rule, so the derivative of 3x is just going to be 3, and then it's going to be 3 times the cosine of 3x dx. So I have a factor of a 1/3 du, and that is equal to cosine of 3x dx. Okay, so then when I do my substitution, I have a 1/3 out in front, and then integral, and then it'll be u to the 5th du, and that is equal to 1 over 18 u to the 6th plus c. And then substituting u is equal to sine of 3x, I end up with 1 over 18, and then sine to the 6th 3x plus c. Okay, the last problem on this page. Note that a is a constant, and so first thing I'm going to do is I'm going to rewrite cosine cubed as a cosine squared. So then I'm going to rewrite this as integral of cosine squared a times t. So a is the constant and t is the variable, times another cosine of at dt. Okay, so on this one right here, I'm going to rewrite this using my Pythagorean identity, right? So I'm going to rewrite this one as 1 minus sine squared of at. Okay, so then that's going to equal integral 1 minus sine squared at, and then I'm going to multiply that by what I have left over there, which is cosine of at dt. And then I will multiply through, so then that gives me integral, I'm taking cosine of at times this, so that's cosine of at minus sine squared at times cosine at dt. Okay, so I actually have just 2 different integrals on this, and so with this one I can just evaluate it, and that's going to be just a 1 over a times sine of at, and then for this one I have to do a u sub, so I'm going to so just this one right here, I'm going to do a u sub, And the u sub on this is let u equal sine at. So du is going to equal a cosine at dt. So then you have 1 over a du is equal to cosine of at dt. Okay, so then putting that together, just this part right here, you have a negative out in front, so then that'll give me a minus 1 over a, and then it's going to be integral of u squared du. And then evaluating that, I'm going to just rewrite this part here, 1 over a times sine of at minus 1 over, and then I have a factor of 3 from the integral, so it's 3a, and then it's u to the third plus c. And then for my final answer, I need to substitute in u is equal to sine of at. So I have 1 over a sine of at minus 1 over 3a times sine cubed at plus c. And you should also state in this that a cannot equal 0. So this is where a cannot equal 0. Okay, that's it for page 11.